Welcome to the deep dive. Sometimes you just have to pause and think about human ingenuity. It's incredible what we can create. But there's also this immense power for, well, destruction. And that's what we're grappling with today, nuclear weapons. It feels like history, maybe, but it's very much shaping our world right now. Our source for this deep dive is really compelling material called Nuclear Impact, Science and Geopolitics of Atomic Power. It includes this quite intense article and video, What if a nuclear bomb hit Washington, D.C.? From the Johnny Harris YouTube channel. Doesn't pull any punches. So what's our goal here? We want to unpack the science, what actually happens in a nuclear detonation, understand the scale, and crucially, figure out why these weapons are suddenly such a big topic again in global talks. We're hoping to give you a way to get properly informed on something that feels, well, both distant and terrifyingly close.
And being informed is, I think, more important than ever. Understanding the science, the geopolitics behind nuclear power, it's not just for the experts anymore. It's really essential knowledge for everyone, for being a global citizen today.
Okay, let's try to visualize the impact. The source paints this picture. A warhead, like a cone, maybe 2 meters tall, coming back through the atmosphere, and for just a moment, it becomes the hottest thing in the solar system. Over 100 million degrees Celsius.
Yeah.
Hotter than the sun.
Yeah, it's almost impossible to comprehend. And upon detonation, the effects ripple outwards immediately. Right at the center, you have the fireball radius. Maybe half a mile across. In that zone, everything is instantly vaporized. People, buildings, the ground itself. It's turned to dust or even smaller particles, just gone.
Complete annihilation.
Exactly. Then moving out, you get the blast wave. This extends maybe 2.5 miles out. And this isn't just wind. It's a shock wave moving faster than sound. It just flattens most buildings. The winds it creates are faster than anything ever recorded in nature. Think about that. Just unimaginable force.
Erasing the landscape.
Completely. And then even further out, say up to 5 miles, you have the thermal radiation. This is intense heat radiation. It causes third-degree burns on exposed skin instantly. And it ignites fires everywhere, just widespread fires merging into, well, a firestorm.
That's the immediate horror, just minutes, seconds even. But then comes the longer-term danger, right? The part that lingers.
Right, that's the mushroom cloud and the fallout. And that cloud, it isn't just smoke and dust like a normal explosion. It's full of radioactive material. The bomb interacting with the ground, with buildings, creates all these unstable isotopes, and they get sucked up into the cloud.
But the dust itself becomes dangerous.
Exactly. The source uses this really powerful phrase, dust is no longer just dust, becomes a slow-motion time bomb, shedding radiation invisibly for thousands of years. It poisons people, the soil, water, everything. It can travel hundreds, even thousands of miles, depending on the wind, a threat that lasts generations.
And that's the impact of just one warhead, which brings us to the scale of modern arsenals. It's not just one bomb we're talking about, is it?
Not at all. The destructive potential is, frankly, staggering. Take a single submarine-launched missile. Our source notes it can carry up to 8 separate warheads.
Elite. On one missile.
8. And if those were all targeted on the same city, you're not just adding the destruction, you're multiplying it exponentially. The overlap creates even more devastation. And the key thing is, multiple countries have these systems. Submarines, silos, bombers, ready to launch on very short notice.
Which leads us to the current geopolitical situation. Because this isn't just Cold War history we're discussing. These weapons are very much back in the conversation now. Why is that?
Well, it's complex, but many experts feel we're entering what they're calling the third age of nuclear power. It's different from the Cold War's bipolar standoff. Now you have more nuclear powers, potential powers, non-state actors as worry. It's a much more complicated picture. You see nations like Iran, for instance, frequently in the news. Lots of secrecy, very high-stakes diplomacy.
Okay, so to really understand the stakes, maybe we should step back and look at the science itself. Where does this almost unbelievable power actually come from?
It comes down to the atom, the fundamental building block, right? Protons, neutrons, electrons. And there's this incredible idea, really profound when you think about it, that matter is frozen energy. All the stuff around us is just packed energy.
Which brings us to probably the most famous equation in history. E equals mass and era. Energy equals mass times the speed of light squared.
Exactly. And that c squared, the speed of light squared, is a huge number, which means even a tiny amount of mass, of matter, holds an enormous amount of energy. The source gives this great example. Take a simple 1-gram paperclip. If you could convert its mass entirely to energy,
how much are we talking?
You'd get 89 trillion joules. Enough energy, they say, to power a single home for maybe 2,000 years. or 100,000 homes for a couple of weeks from one paperclip.
Wow, but obviously we can't just turn paper clips into power plants. There's a catch, right?
Right, a very big catch. You can't easily unlock that energy from just any old atom. For nuclear reactions, the kind we use in bombs or power plants, you need specific types of atoms, ones that are inherently unstable. We're talking about heavy elements like uranium-235 or plutonium-239. Their nuclei are large and kind of ready to break apart.
Okay, so you need these special unstable elements, and there are two main ways to release their energy in these weapons.
That's right. Two main processes, fission and fusion.
Let's start with fission. That's the one used in the first atomic bombs, right?
Correct. Fission is basically about splitting atoms. You take a large, unstable nucleus, like uranium-235, and you hit it with a neutron. When the neutron hits, the nucleus splits into smaller pieces. But critically, it also releases a huge amount of energy, and it releases more neutrons.
Ah, and those new neutrons can then hit other uranium atoms.
Exactly. Those newly released neutrons go on to split other U-235 atoms, which release more energy and more neutrons, which split more atoms. It's a chain reaction. It happens incredibly fast, an uncontrolled cascade. The source mentions that smarter everyday video with the mouse traps and ping pong balls. It's a great visual for how one little neutron can trigger this massive, explosive release of energy almost instantly.
Okay, that's fission, splitting atoms apart. What about fusion?
Fusion is kind of the opposite. Instead of splitting large atoms, you're forcing small atoms together, usually isotopes of hydrogen, like deuterium and tritium.
Merging them.
Yes, fusing them together under immense heat and pressure. When they merge, they form a slightly larger atom, like helium, but the resulting atom actually has a tiny bit less mass than the original small atoms combined.
And that missing mass is converted into energy, following E-Meltdown again.
Precisely. And it turns out that fusing small atoms releases even more energy than splitting large ones with fission. This is the process that powers stars, including our sun.
And it's used in the more powerful hydrogen bombs.
That's right. Hydrogen bombs or thermonuclear weapons actually use a fission bomb just to create the intense heat and pressure needed to trigger the fusion reaction. So you get an initial fission explosion, then a much, much bigger fusion explosion, far more powerful than the early atomic bombs.
So bringing this all back to the present day,
Mm-hmm.
we have this incredible power, fission and fusion, locked in arsenals. Why does it feel like nuclear weapons are suddenly such a pressing issue again? It seemed quieter for a while.
Well, I think it connects back to that third age idea and shifting global dynamics. There are renewed tensions, definitely. You see major powers like Russia, China, the U.S., all modernizing their nuclear forces. And then you have regional situations like North Korea's continued development or the complexities around Iran's nuclear program that we mentioned. Nations are actively developing new delivery systems, hypersonic missiles, things like that, and they're making nuclear capabilities a much more explicit part of their national security strategy again.
So there's this pervasive feeling of uncertainty, maybe even escalation. It does have a sort of Cold War echo, but maybe more complex, more unpredictable.
I think that's a fair assessment. That sense of uncertainty is palpable, and it makes understanding all this, the science, the strategy, the players, really vital. It's not just academic.
Absolutely. And given how high the stakes are and how complex it all is, navigating the information itself becomes a challenge, doesn't it? Especially with different countries, different media outlets presenting things differently.
It really does. And our source material actually touches on this directly, pointing out how difficult it can be to get a clear picture when the narratives can vary so much depending on who's reporting.
Right, which is a crucial skill for all of us today, figuring out what to trust.
Yeah.
Does the source give any pointers on how you, the listener, can approach this?
It uses the example of reporting on Iran's nuclear activities. It contrasts how, say, a news outlet funded by Qatar with a generally left-leaning perspective might frame a story suggesting Iran is downplaying a threat, versus how a right-leaning outlet based in Israel might run a headline claiming Iran has enough enriched uranium for, say, 10 bombs. Very different framings of similar underlying facts, perhaps.
So the takeaway isn't about which one is right, but about awareness.
Exactly. The emphasis is on you, the listener, needing to be proactive, to compare different sources, to ask questions. Who is funding this report? What might their perspective or agenda be? It's about trying to see the bigger media picture, recognizing potential bias, and piecing together a more informed understanding yourself, not just taking one report at face value.
Be an active, critical consumer of information. That makes sense. So wrapping this up, the core message from our source seems pretty clear. Nuclear weapons aren't just a dusty chapter in history books. They are very much a now issue.
Absolutely. And understanding the science behind them, the politics surrounding them, it's not just for specialists anymore. It really is essential knowledge for every citizen in today's world.
So we'll leave you with this thought to consider. With this renewed global focus on nuclear power, what does that really mean for the future of how nations interact? And maybe more importantly, what role do you think informed citizens like you play in shaping whatever that future holds?